Imagine a standard horizontal number line. It is an incredibly reliable tool for tracking values along a single flat path. If you need to find the number 4, or -2, you simply slide along that one axis until you hit your mark. The location is perfectly exact. But notice all the empty, featureless space floating directly above and below that line. If we try to locate a point floating in that open space by saying it is 1 unit away from 0, the system breaks. In 2 dimensions, 1 unit away forms a complete circle. That gives us an infinite number of possible locations along that radius. We have no way to pinpoint the exact spot. A single dimension traps our ability to measure. To navigate a flat surface accurately, we have to invent a completely new dimension of measurement. In 1637, a French mathematician named René Descartes found a solution while exploring how to map 2-dimensional space. He took a second vertical number line and dropped it right across the first one at a perfect 90-degree angle. The exact center, where these 2 lines intersect, becomes the universal starting point for this map. We call this the origin, 0, 0. From that origin, the horizontal line stretching left and right is officially named the x-axis, and the vertical line reaching straight up and down is named the y-axis. By locking these 2 perpendicular lines together, Descartes turned a featureless void into a perfectly measurable grid system, the Cartesian plane. To navigate this plane, we use coordinates. These are ordered pairs of numbers, written in parentheses, which act as a precise address on the grid. Let's test this by plotting a specific location, point M. We always begin our journey right at the origin. First, we read the x-coordinate. If that number is a 4, we move our indicator exactly 4 units to the right along the horizontal axis. Next, we read the y-coordinate. If it is a 3, we travel straight upward from our current spot, moving 3 units high, parallel to the y-axis. Our journey ends there. We drop a point on the map and label it M43. By strictly following this horizontal then vertical rule, every ordered pair locks into one unique spot. No 2 locations on this grid can be confused or misplaced. The true power emerges when plotting multiple coordinates in sequence. Connecting these precise points with straight lines, A to B to C to D, instantly constructs a closed 2-dimensional shape. By manipulating these pairs, we can perfectly duplicate the shape, creating flawless mirrored symmetry. This process translates the abstract language of numbers directly into the visual language of physical shapes. This grid system provides the basic logic for how we interact with digital displays today. Every image on a screen is essentially a dense map of coordinates. By expanding these 2 axes into a 3rd dimension of depth, software can calculate the exact position of thousands of vertices to create a 3-dimensional model. What began as a way to find a dot on a page became the standard for simulating and navigating physical space inside a machine.